Hello, Algebra Tours. We are finally finishing this foldable. So we are in the last flap of that big foldable booklet foldable on factoring. So we're going to talk about a special case of factoring today. And you're going to need a pen or pencil, that booklet that should be in your notebook, a calculator, and most definitely your thinking caps. So before we dive into the flap or the foldable, I want to quickly ask you, do we remember how to multiply or FOIL or double distribute? Well, if we don't, let's just jog our memory. So you don't have to answer these questions. Just follow along with me to make sure we remember how to double distribute or to FOIL. So if we want to multiply these two things out, we're going to get x times x, which is x squared, x times a negative 3, which is negative 3x, 3 times x, which is plus 3x, and 3 times a negative 3, which is a negative 9. If we simplify this guy, our middle terms go away. Negative 3x plus 3x or 3x minus 3x eliminates this thing in the middle. So we're left with x squared minus 9. Let's try another one. We have 2x plus 7 and 2x minus 7. So let's multiply these guys. So we're going to take 2x times 2x for 4x squared. 2x times a negative 7, which is a negative 14x, 7 times 2x, which is a positive 14x, and then 7 times a negative 7, which is a minus 49. Just like the last one, we have a negative 14 and a positive 14, which is going to cancel my middle term, or it's going to add to 0, so we can get rid of those. So I'm left with a 4x squared minus 49. So what we're going to do today is we're going to start with this and we're going to work our way back to figure out what two things were in the set of parentheses from the two terms. So up until this point, we have been factoring things by the GCF. If not by the GCF, if we've had 4 terms, we've done it by grouping, and then we did 3 terms. Now we're going to learn a special way to factor because this is a special case, and this is going to be called the difference of two squares. So we are in this flap of your foldable, the difference of two squares. So if you want to open that up, that is where we will get started. All right, so the difference of two perfect squares when we have two terms. The first thing we want to do is identify some of the following. Do we have a difference or do we have a negative sign? So do we have a difference or do we have a negative sign within the two terms or between the two terms? And then are we going to notice that the two things, the first term and the second term, are perfect squares? If that's true, if we have two terms where the middle sign is negative and the first thing and the last thing are perfect squares, then we're going to use the square roots of both of those terms to get our answer into two factors where one's positive and one's negative. So make sure you get these in your notes, these top bullet points, before we do the 7 examples, okay? So if you need to pause your video to get that into your notes, please do so. Alrighty, I just zoomed in a little bit so that I can have a little more room to write for each of these examples, but you can write them directly into your foldable. So let's look at example number 1. We notice that we have two terms. We have an x squared and a negative 49, and we know that we have a subtraction sign or a negative sign in front of the 49, and we know 49 is a perfect square. You guys, perfect squares, if you want to write this beside your foldable or somewhere on your foldable, you can do so, are numbers where if we said 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Perfect squares are the numbers that happen after you've squared a number. So 1, 4, 9, 16, if we kept going, like 25, 6 squared is 36, 7 squared is 49, 8 squared is 8 times 8, which is 64, 9 squared is 81, and we'll stop at 10 squared, which is 100. And we could keep going, right? So perfect squares are all the ones on the right hand side. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. We could keep going to 121 and on and on and on and on and on, right? So in this first example, we know that 49 is a perfect square. That's what I was trying to say. So we set up our two sets of parentheses, and we know that in order to get to the last term, 49, we need 7 times 7 to get back to 49. And in order to get to x squared, we need x and x. Now, this is the part at the top of your notes that you should have set up top, that one of them is going to be positive and the other one is going to be negative. Think back to those examples that we multiplied out at the beginning of the video when we had x plus 3 times x minus 3. When we multiply these out, you guys, that's when the middle term gets erased or goes away. So that's why when we're going the opposite direction with factoring, we say, well, one of them has to be positive and one of them has to be negative, okay? So let's try example number 2. We're going to have two sets of parentheses. Now, with this first term, we have 4x squared. So we know we have to have an x and an x, but we know 4 is a perfect square. So the square root of 4 then would be 2. So when we would put 2x as our first term in both sets of parentheses, we know we needed to do 2 in both of them, because if we take 2x times 2x, we get back 4x. And then the square root of 9 is 3. And then we make one of them positive, one of them negative. Okay, the next one is 81 minus w squared. So now we still have that negative sign in between. And it's okay if the variable is at the end and not at the beginning. Now we're just going to have 9, because the square root of 81 down here is 9. 9 times 9 gets us back to 81. W times w gets us back to w squared. One of them has to be positive, one of them has to be negative. Okay, example number 4. We just need the square root of 16x squared, which is 4x in our first spot in our sets of parentheses, and the square root of 25, which is 5. Make one of them positive and one of them negative. Example number 5. We have 4x squared minus 7. 7 is not a perfect square, so we got to figure out a way to do this. So we know 4x squared, the square root of that is going to be 2x, but in our list we don't see 7 between 4 and 9. But we do know that what we're doing to get this number, this last term, is we're taking the square root of this perfect square to get the number that goes in the last spot of our sets of parentheses. So instead of saying a number like we did, the square root of 25 is 5, let's just say the square root of 7. Because it's not a clean number and it's a gross decimal, we're just going to say the square root of 7, positive, negative. So even if this last term is not a perfect square, we can still just write it as the square root of 7 in both sets of parentheses, because that's ultimately what we're doing, is we're taking the square root of the first term and the square root of the second term. Okay, example 6 and 7. Sometimes we need to remember to take out a GCF first. Just like we learned yesterday and a couple days before, it's best to take a GCF out right away, because that usually makes our lives easier. So 5x squared and 20 have a 5 in common, so let's take that out right away. So then we're left with x squared minus 4, and now we see a difference of 2 squares because we have x squared minus 4. So bring down the 5. We need 2 sets of parentheses. We know my first term, to get to x squared we need x times x, so I put x's in my first spots in my 2 sets of parentheses. To get to a negative 4, we need to take the square root of 4, which is 2. Opposite sign, so a plus 2 and minus 2. So 5 times x plus 2 times x minus 2 is my final answer. And now number 7. So we need to figure out what it has in common. So 2x cubed minus 72x. What GCF do they have in common? Well, 2 and 72 have a common variable, or sorry, common factor of 2, and they also share a common variable, which is just x. So if we divide out a 2x from each of those terms, 2x cubed divided by 2x gets me, 1x squared, and then negative 72x divided by 2x gets me a negative 36. So we know that x squared minus 36 is a difference of 2 squares. So bring down my 2x in front of my two sets of parentheses, and we know that the square root of x squared is just x, or in order to get an x squared as a first term, we need an x in both parts of the front of our sets of parentheses, and then the square root of 36 would be 6, and we need one of them to be positive and one of them to be negative. So my final answer is 2x times x plus 6 times x minus 6. Alrighty, ladies and gentlemen, that completes our entire factoring booklet note packet. Thank you so much for watching this video, and I shall see you soon.